Hi, welcome to Section 7.2 Notes on Similar Polygons. So similar figures are the same shape, but not necessarily the same size. And two polygons are similar if corresponding angles are congruent, and if the lengths of the corresponding sides are proportional. Okay, and the similar symbol is a little squiggly line. So it's kind of what's on top of the congruent symbol, not the equal sign part. So if we're talking about two figures being similar, you can look at these two figures here. Again, we just said they're the same shape. They look the same, but they are not the same size. One's bigger, one's smaller. And if the two are similar, this is called a similarity statement. Just like when we said triangles were congruent and the order of the letters told you a lot of information, same thing with this similarity statement. The order of those letters tells you lots of information. You can see that it tells you the corresponding angles that are congruent. So first letter, angle A is congruent to angle E. Second letter, B is congruent to F. Third and third is C and G. And last letter is D and H. All right. And then, but the corresponding sides are not congruent. They are proportional. We can obviously see they're not the same length, but here's where we talk about the lengths being proportional. If I take two corresponding sides and write them as a fraction or a ratio, then all of those fractions or ratios of the corresponding sides should be equal to each other. So I don't want to mark them congruent because they're not congruent. But just kind of pay attention to what is here. You know, AB is this length over EF, this length. Again, both of those lengths are between the 1 and 2 mark, between the 1 and the 2 mark angle. So I know those two correspond with each other. I can see the next two, BC and FG, is referring to this one and this one. Okay. I can see that, you know, the next ratio, CD over GH, that's referring to this one and this one. And then obviously the last two, you know, this one and this one with the dots by it are the last two, AD over EH. All right, next is the scale factor. So the scale factor is a ratio of two corresponding lengths of two similar figures. So we can see an example 1 here. It says that triangle RST is similar to triangle UVW. Find the scale factor and then find X. So in this particular case, if it wants me to find the scale factor, I just need to find two lengths that correspond with each other, write it as a ratio, and then simplify down that ratio if possible. So if I look at these two triangles, in the triangle on the right, the only side length that I know is 2. And I can see that as UW, and I can see that UW are the first and the last letter here. So I know that it has to correspond with the first and the last letter here, which is R and T, which is this 4. So sometimes they will specify how they want you to write the scale factor. Like they'll say the scale factor of triangle RST to UWV, and that would mean to put the 4 over 2. If they say find the scale factor of triangle UWV to triangle RST, that would mean put 2 over 4 and then reduce it down. If they don't specify, I guess it doesn't particularly matter which way you write it. You just need to be careful with what you're writing the scale factor to be, so that if you're trying to find a missing side length using the scale factor, that you do the right thing with it. Do you multiply to get a bigger number, or do you divide to get a smaller number, and so forth, depending on what number you're dealing with. So in this particular case, we have RT over UW. And so that ends up 4 over 2, which reduces down to 2. So the scale factor of triangle RST to UWV is 2. Everything on the triangle left is twice as big as the triangle on the right. Now, if they want us to figure out what x actually is, there's two ways you could do that. You could either use the scale factor and think, okay, I know the scale factor is 2. So if I know one side length is 7, then I know that I just need to find x. I just need to go 7 divided by 2, which is 3.5. And that would give me what x is. That's one way to do it, is using the scale factor. The other way is to set up a proportion. Okay, I could say 4 over 2 is equal to, now I can find two other corresponding pieces that match up, and is equal to 7 over x. And then I can cross multiply and solve. So I get 4x is equal to 14. And then when I divide by 4 on each side, I get x is equal to 14 over 4, which reduces 7 over 2, which gives me 3.5, which is the same thing we mentioned before. Okay, next up on example 2 says that these two triangles are similar to each other. Name a pair of congruent angles. So again, first letter, I know angle M is congruent to angle S. Middle letter, angle N is congruent to angle R. And last letter, angle P is congruent to angle T. If you prefer to mark that on your picture as you go, that would be fine. M and S, and N and R, and P and T. Okay. So then on part B, it says write the ratio of the corresponding sides. It's an extended ratio. So I can see first two letters, M, N over SR is equal to last two letters, NP over RT. And then first and last, NP over first and last, ST. All right. From there, on example 3, it's asking, are the following polygons similar? If so, write a similarity statement and give the scale factor. So in this particular case, if these are both equilateral triangles where all the side lengths are congruent and all the angles are congruent, then if we want to see if they are similar or not, again, corresponding angles are congruent. We can see that because all of those angles must be 60. Corresponding side lengths are congruent. Do they have the same ratio or scale factor? I can see if I take one side length from this triangle and one side length that corresponds with it on this triangle, I get 9 over 15. And that reduces down to, if I divide by 3 on the numerator and denominator, I get 3 over 5. Obviously, since all of the side lengths are the same, 9 over 15, 9 over 15, those also reduce down to 3 over 5. And so, yes, they are similar to each other. Okay, the corresponding angles are congruent and the corresponding sides are proportional, or they have the same scale factor. Next, it says, if so, write a similarity statement. So I can say triangle ABC is similar technically because they're both equilateral triangles and all the sides and angles are congruent and corresponding sides are proportional. And technically it doesn't matter what order I put these letters in. So I'm just going to say triangle FED. All right, from there, I can say what the scale factor is. And basically I already found the scale factor. I already said it was 3/5. I don't need to rethink that. Okay, on the one on the right, then again, if I want to see if they are similar, I can already see that the corresponding angles are congruent to each other. Now I need to see if the corresponding sides are proportional. So if I say smallest length over smallest length, 16 over 8, I can see that reduces down to 2. If I go medium length over medium length, which is 30 over 15, that reduces down to 2. And largest over largest is 34 over 17, which reduces down to 2. So are the polygons similar? Yes. Corresponding angles are congruent. Corresponding sides are proportional. So I can write a similarity statement. I can say triangle KJL. Again, it doesn't matter how you name the first triangle, but if I chose to go KJL, 1 mark, 92 mark on the angles, I need to follow that same pattern on the other side, 1 mark, 92 mark, so QPR. And then the scale factor that we already found is 2. All right, next up, a lot of this is very similar to what we just did. It's just going to give you some extra examples, which I think will be helpful. So we'll go ahead and take the time to go through that. This top part is kind of a review. If you want to try to fill it in and then check back with the video, you can do that. But again, similar polygons are polygons that have the same shape and may be a different size. 2 polygons are similar if and only if their angles are congruent and the measures of their sides are proportional. The order of the vertices is important in a similarity statement, just as it was in a congruent statement. You write a similarity statement with sides in corresponding order and with angles in corresponding order. If a similarity statement is given to you, this identifies the congruent angles and the proportional sides. When 3 or more ratios are equal, you write an extended proportion. Say extended ratio. Okay, next up on example 1, it says determine if the triangles are similar. So again, similar to what we were doing on the other side. But it also says justify your answer. So we need to put into words a reason for that as well. So in this particular case, I can see if I have a 90 and a 30. If I add those up and subtract from 180, I get 60. And 90 and 30, add them up, subtract from 180 and get 60. So I can already see my corresponding angles are congruent. I want to see if my corresponding sides are proportional. So I can see that the 12 that's between the 30 and 60 and the 9 between the 30 and 60 correspond with each other. So I can write those as a ratio, and I can reduce them down to 4/3. Next up, I can see the 6 and the 4.5 correspond with each other. They're between the 60 and the 90. So if I go 6 over 4.5, then if I want to reduce that down, one way to do that is to multiply the numerator and the denominator by 10, which will give you 60 over 45. And then I can divide the numerator and denominator by 15, and that gives me 4/3. All right, and then lastly, we've got 6 square root of 3 over 4.5 square root of 3. And in this case, hopefully you're seeing that the square root of 3 is actually can cancel out. And then I'm left with 6 over 4.5, which I already did the work in blue right there. Will reduce down to 4/3. I don't need to do that work again. And so now I can see that, yes, these figures are similar. And the reason that I could justify it, as I could say, corresponding angles are congruent and corresponding sides are proportional. Okay, moving on to the next one. If we look at the next one, we can see that if we kind of follow the same process, we do see corresponding angles are congruent. They're all 90. But if I pick the smallest length of this figure over the smallest length of this figure and write that as a ratio, 6/5. Now if I pick the biggest length of this one over the biggest length of this one, 7/6, those two ratios do not reduce down to the same thing. And so these two figures are not proportional. So I can say no corresponding. That does not look very good. I'm going to retry that word. There we go. Corresponding sides aren't proportional. All right, and I can show that by saying that 6/5 is not equal to 7/6. All right, next up, it says that example 2, it's telling you a similarity statement, and they want you to say what the pairs of congruent angles are and what is the extended proportion. We've already done one like that. Again, if you want to pause the video and try that yourself, that would be good practice. But you should end up with angle M is congruent to angle S. You should end up with angle N is congruent to angle R, and you should end up with angle P is congruent to angle T. Our extended proportion is, again, corresponding sides written as ratios. So MN, first two letters, over SR, first two letters, last two letters NP over last two letters RT, and first and last NP over first and last ST. Then here, scale factors, just reminding us that the ratio of the corresponding linear measurements of the two corresponding sides. And, if you want to show the scale factor for these two figures, again, I can say 15 over 6, smallest over smallest, and that reduces down to 5/2. If I go medium over medium, I've got 20 over 8, which reduces down to 5/2. And then I can say 25 over 10, which also reduces down to 5/2. And so again, the corresponding angles are congruent. I can see that in the picture. Corresponding sides are proportional. They have the same scale factor or ratio. So yes, those two figures would be similar. On example 3, it says, are the figures similar? Again, same directions. This is just giving us lots of practice and lots of examples here. So on A, we can see that the corresponding angles are congruent. But if we go ahead and check the corresponding side lengths, we can see that between the 1 and the 2 marked 6 and the 1 and the 2 marked 6, I can write that as a ratio that reduces down to 1. If I go ahead and pick the next length and I pick 12, let's use a different color. 12 over 6, they're between the 1 mark and the 90, and I write that as a ratio, I can see that go reduced down to 2. So already, if I see that those two ratios are not the same, then I can say, no, these polygons are not similar. I don't have to check the other ones once I get a no. All right, on B, same directions. But in this case, I do see corresponding sides are congruent. Corresponding angles, corresponding sides. If I go smallest to smallest, medium to medium, and largest to largest, I can reduce those down. So that would give me 4/5. I can reduce that down to 4/5. And I can reduce this one down to 4/5. And so again, in this case, I would say, yes, these two triangles are similar. It says write a similarity statement. So triangle PQR is similar to 1 mark, 2 mark, 3 mark, STU. And the scale factor is 4/5. All right, next up, we are almost there. On example 4, it says the two polygons are similar, write a similarity statement. So I can tell kind of by the shape of the figure, the similarity statement in this particular case. So if I look at the bottom figure first and call that A, B, C, D, E, because it makes that easy to write, then that corresponds with, in the top, same order, R, S, T, U, V. So R, S, T, U, V. is similar to A, B, C, D, E. From there, we can set up a proportion and a cross multiply. So in this case, the x corresponds with the 3. And that's equal to the 18 over 4. And when we cross multiply, we've got 4x equals 18 times 3, which is 54. And if I go ahead and divide by 4 on both sides, I get x is equal to 27 halves. Or I can go and divide that and get 13.5. Or if you wrote 13 1/2, that would be fine also. All right, from there, if we go and set up a proportion, we can use that 18 over 4 just like we already did. But we can also pair that up. If I want to figure out what y plus 2 is, I can see it corresponds with the 5. So I can say y plus 2 over 5. So when I cross multiply here, I want to make sure I remember that 4 times y plus 2 is equal to 18 times 5, which is 90. Okay, I want to make sure that y plus 2 is in parentheses because I want to remind myself that I need to distribute here. And when I do that, I've got 4y plus 8 is equal to 90. If I go and subtract 8 from both sides, I get 4y is equal to 82. And then if I go and divide by 4 on each side, I get y equals 41 halves, or 20.5. Okay, last little bit here says also find ut. Well, I can see ut is y plus 2, but we just found that y is 20.5. So I just need to add 2 to that. So that means I get 22.5. And that's it for ut. Okay, part B also wants us to find the scale factor. Well, we've already been using the scale factor. It's this 18 over 4. Those are two lengths that we know that we can write as a ratio. It says this one to this one, so that's what's telling me that 18 goes on top and 4 on the bottom. And then I can just reduce that down to 9 halves. All right, big finale here. On example 5, it tells me the two figures are similar. Wants to know what x is. It's not even asking what y is. I can just set up a proportion. So I can see the x corresponds with the 7.5. And I can see that I went smallest to biggest. So I'm going to stay consistent when I set a proportion. Now smallest 6 over biggest 9. And if I cross multiply, I get 9x is equal to 6 times 7.5, which is 45. And I go ahead and divide by 9 on both sides. I am left with x is equal to 5. And that's all it's asking for on that one. All right, let me know if you have any questions.